In this question, there is two problems. One is the half wave rectifier, okay, and another is a capacitor filter, okay. Explain the operation of the circuit. So what I will do, first I will explain you the operation of the half wave rectifier. Okay, this is V0. First you need to understand two things. Here, if there is no diode, then you all know, if the diode is not here, this is just a voltage follower circuit with the unity gain, right? That means this is the Vi, so we can write down V0 is equal to Vi or equal to V0 sine omega t, right? That means when if the diode is on, then this particular circuit will work like this, right? And if diode is off, then how the circuit will looks like? What will be the value of V0? V0 will be equal to 0. Why? You can see there is no connection between the output of the op-amp and the V0, right? And as this is a open loop op-amp, that means there is no feedback. That means that this op-amp will work in the saturation region, right? And in the saturation region, there will be no virtual short. That means the V plus is not equal to V minus, right? And as there is nothing in the V minus, what will be the value of V0? V0 will be 0. Okay, so you already understand, if the diode is on, then the circuit will look like this. If the diode is off, then circuit will look like this, right? Now we need to see that when the diode is on, when the diode is off. Okay, first I just draw the sine wave. Okay, right? I assume that this diode is ideal diode. Okay, first assume that there is no capacitor. Okay, this is disconnected. Then we will show you the operation of capacitor. When the input voltage Vi is in the positive waveform, positive half cycle, at that time the input voltage at the V positive is positive, right? That means we give the input is positive, right? And we all know that the formula of V0 is equal to AT is V plus minus V minus, right? And we give the input voltage V plus is positive, right? And in the V minus, we didn't give any input. That means we will get a positive voltage at the output, as we are giving the positive voltage in the non-inverting terminal. That means here we will get a positive voltage, right? And here we didn't give any input in the negative terminal, right? That means that is 0. So here we get a 0 volt, right? That means if this is V1 and if this is V2, then we can write down V1 is greater than V2, right? If V1 is greater than V2, then this diode D1 will be in the forward bias. Okay, as this is the ideal diode, with only this condition, this diode is in the forward bias. But if this is a practical diode, then what should we do? Then V1 minus V2 should be greater than 0.7 volt. That means when this input voltage is greater than 0.7 volt, at that time this diode will be turned on. But as this is the ideal case, when the Vi is just increased from 0 to positive voltage, at that time the diode will be turned on, right? And if the diode is turned on, I already show you that this circuit will be looks like a voltage follower circuit, and the output will be same as the input voltage, right? That means we will get sine wave in the output. Understood? No problem in that one. Now go to the negative half cycle. So for the negative half cycle, now the input is switch from positive to negative, right? That means the value of Vi in this instant will be equal to negative. Okay. Here the formula will be V0 is equal to AD into V plus minus V minus, right? Here V minus is 0 as I didn't give any input, okay? And V plus is how much? V plus is in negative. So eventually you can see here we will get a negative voltage, right? And we all know if we get a negative voltage here, is V, suppose this is a V1, get a negative voltage here, the diode will be off. Why? Suppose this is the diode and here is V1 and here is V2, right? And this is the negative voltage and V2 I didn't give any voltage, that means 0. So V2 is a higher voltage, V1 is a lower voltage, that means the current should flow from V2 to V1, right? But diode will not conduct in this particular condition. Why? In this case diode is in reverse bias, okay? That means diode will be turned off, okay? And I already told you in the last slide, if the diode is turned off, then you can see this is the open circuit, right? That means the output will be 0, right? I just redraw that one again. Suppose the diode is off, right? That means the circuit will looks like this one. This is plus, this is minus, Vi and V0, right? Okay, so V0 is not connected with the op-amp output, and in the negative terminal I didn't give any voltage. That means V0 should be 0. So what we will get? We will get here is 0, and here again we will have a positive, and here we will again have a positive. So this will repeat, right? That means this circuit will act as a rectifier. Okay. So this will act as a half wave rectifier. Okay. So now you already understand the work of this particular area without any capacitor, right? And with this particular area of the circuit give us a rectifier, half wave rectifier. Okay. So what we need to do now, we need to draw the circuit again for the capacitor load. Here the load is capacitor, right? So here we can draw that we have a voltage source. Here is Vi, okay, and we have a capacitor, right? And here this Vi is the this input voltage. Suppose this is Vx, so this is Vx, okay? So Vx is nothing but a half wave rectifier output, okay? So that means what we will do, this will act as a capacitor filter. And how it will work, I already have a dedicated video for the capacitor filter. I will put that link in the description. Please go and watch that one if you didn't understand here, okay? I will explain you again in this one. Suppose I redraw this one, okay? This is Vx, and here we have like this, okay? And suppose this is the output we are drawing. So this is V0. So I just do a dotted line of the input voltage. Now you can see here. You all know capacitor is act as a battery, right? That means the capacitor will charge with a particular voltage. And you all know that when you add a capacitor in a circuit, then the voltage will build up like this, right? That means when you add a voltage source into the capacitor, then the capacitor will charge with that particular voltage, right? That means if I take another color, then when the input voltage is this, then capacitor will take the voltage and do the charge, okay? And it will go up to this line where the input voltage is maximum, okay? Now see this. Here you can see for the capacitor in the charging cycle there is no resistance R equal to 0, right? That means the time constant for the charging is very fast, is 0. That's why it will exactly follow the input voltage curve, okay? Now for the output also you can see the output R is infinite as there is no resistance in the output. So the time constant for discharge will be also infinite. That means when the capacitor will fully charge in this point with the maximum voltage, after that there is nothing for the capacitor to discharge, right? So the capacitor cannot discharge. as the resistance is here is infinite. So there will be no current flow through the resistance, right? That means the capacitor will not lose any of the charge, right? That means the capacitor voltage will be kept constant and it will be constant like this, as there is no resistance in the output. Okay, but suppose you have a resistance here, then what will happen? Then this capacitor will discharge with the depend upon the time constant of the resistance, like this. Suppose this resistance is R1 and this resistance is R4. So we can write down R4 should be greater than R3, should be greater than R2, should be greater than R1. Okay, so this will be the answer. That means if we do the whole thing together, then what we will get? This will be the input voltage. So the input voltage will be sine wave. Okay, and the output voltage will be how? The output voltage will be looks like this one. Up to the first peak, it will go or follow the input curve. Okay, and then it will be kept constant. Okay, so this will be the output voltage. So this is all about this circuit. In all of this previous question, this is the only question that is little bit difficult. Other is everything is okay. If you didn't understand this problem, please let me know. I will explain you again. So now what we need to do? We need to simulate this circuit and see what will be the output voltage. Okay. At this instant, I didn't connect the capacitor. I just connected resistance, okay? Normal resistance, just to show you that what will be the output voltage, okay? And here you can see that there is a three voltage. One voltage is this one, another voltage is this one, and another one is the output. The blue one is the output voltage, okay? And the green one is the just before the diode at that particular node, what is the voltage, okay? And the orange one is the input voltage. If you see the output voltage at the just before the op amp, the green one, you can see this will follow a sine wave, okay? When the diode is on. When the diode is on, this particular circuit act as a voltage follower. So it will just follow the input voltage, right? You can see here, just like that input voltage. But when the input voltage goes to the negative half, at that time you can see the positive terminal. At that time, I already explained you, at the positive terminal, we are giving the negative voltage, right? That means the output should be negative. So you can see the output of the op amp is minus 15 volt. That's why the diode will be turned off. If you see the top waveform, that is just the output after the diode, and you can see that is a perfectly half wave waveform. Okay, so if I just do in a same one and I just delete the this one, you can see the blue one is the output voltage and the orange one is the input voltage. Okay, orange one you can see, we can see the full sine wave, but in the blue one you can see the half sine wave. Okay, so this is the circuit without a capacitor. So what we need to do? We need to connect a capacitor. So now you can see here that the output voltage is constant. Why? When the just circuit started, at that time the blue line is just follow the orange line. That means the input and output is the same. Okay, and when it just go reach to the max one, the peak, then capacitor don't have any path to discharge the voltage. Okay, discharge the charge, right? And as there is no path to discharge, the capacitor hold it voltage, and you can see this one, the output is the constant. Okay, now I will show you if I connect a resistance, then what will happen. Now you can see it looks like that it follows the same path, right? But it depends upon the resistor. As you can see, the resistor is already 10K. Now, if I decrease this value, very beautiful, right? As you can see, it's only 10 ohm. So it is discharging through the 10 ohm. Now, if I just increase a little bit, you can see the slope is increasing, right? And if I just decrease that one, You can see, right? You understand? So the slope of that one is completely dependent upon the resistance, right? And if that resistance is too much high, like 10K or 30K, you see, it's just the constant, right? So in the CU exam paper, they just provide us the capacitor with an infinite resistance, right? That's why it will be, output will be constant. Okay, think you understand the concept. Okay, you don't need to write down everything in the paper. This is just for your concept. Okay, in the paper, just do the calculation, just so that this is the half wave rectifier. I connect a capacitive filter, and as this is a capacitive filter without any resistance, then there will be no discharge, as the discharge time, if time constant, will be infinite. So it will just a peak detector circuit. Okay, thanks for your time. Please do share this concept with your friends, and if you like this video, please press the like button. It is really means a lot for me. Bye bye.